Hi, today we're going to go over some proofs, how to prove triangles congruent. And just to remind you that we have 5 ways to do that. Side, 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 angle, side, angle, side, angle, 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 side, and HL. So we're only going to have to prove 3 things each time. Okay, so when you look at the proof, first let's look at the given information. And this information is already in the picture. So I'm just going to go ahead and list this. I know that PTR is congruent to RSP. Now, I'm not really sure why it's not listed as given, but we also know this green side here is congruent to the other green side because it is marked for us. So let's go ahead and list that. That's not an angle. Let's go back. That is PT is congruent to RS. And that is also given. And honestly, guys, this should be up here. There. Now, the third piece of information, I am giving you the hint that here's the information. Hopefully, you're understanding that we need 3 pieces of information. We have 2. If there's something that's implied within the picture, we need to mark it. So these 2 angles are vertical. And we know vertical angles are congruent. So we can prove this by the vertical angle theorem. So remember, we can write VAT for vertical angle theorem. All right, so we're down to the last step, and we know what you're proving here always goes in as the last step. Now this is called your congruency statement. The first triangle could be in any order if you were writing your own. The second triangle, you would have to write it in corresponding order. So for instance, this first letter, the P corresponds and is congruent to the R, and so on. Okay, so now it's time. Which one of the 5 are we going to prove this by? So we have 2 angles and a side. So if we have 2 angles and a side, it has to be either ASA or AAS. Now, it all comes down to where are the angles and where's the side. So here's an angle and here's an angle. And is the side directly in between it, or is it like down around the corner? And as you can see, the side is like way down there. So it's not ASA. You're going to prove this by AAS. All right, good. So let's go ahead and look at the next one. All right, so we have some given information. Sorry, my cat is not cooperating. Okay. Now, we have given written twice, but only once at the top. Again, that's not real helpful. We're going to take this given information and we're going to write it in the first step. So we have KJL is congruent to MNL. And that's these 2 little angles here. So these 2 sides, again, I'm not sure why these aren't listed here. We need to list those. Now, it looks like some of the letters got cut off, so let's just make up some letters. I think that might have been an N, and let's call that an O. Actually, we could figure that out here. J. Here, I'm backing up. 1 second. I can figure this out by looking at my congruency statement and seeing which letter is missing. So K, L, and so this was a J. And that was an N. Okay, good. So the other given information is that the 2 green sides are congruent. So KJ is congruent to MN. And that's given. Again, I'm giving you this third piece of information. So how do we know this? And they're right there. We know it for like we did before. These are vertical angles. So we're going to say this is the vertical angle theorem. Okay, so we have two sets of angles. Now this says we're going to use the third angle theorem, which says if you have two angles in common, the third angle also has to be in common. Okay, so that means K and M also have to be congruent. So angle K is congruent to angle M. So we're going to prove our triangles. I'm just rewriting it from up above. Our two triangles are congruent. Again, this is called your congruency statement. And we need to figure out why. So with this one, again, how many choices do you have? You have 5. Here they are. Now, we know it's not HL. HL, you have to have a right triangle. We don't have all 3 sides. So here's the thing. We have 3 angles and a side. So there's going to be multiples that this one could be. So since they made us do step 4, I'm going to guess that let's just use K and M. So I'm going to use K and M. And so if this is the case, I could use this information here and do angle, angle, side. Now, what if you wanted to do a different way? Is it possible? And I can tell you it is possible. So if I have all this information, I'm just trying to get my picture back like it was. I could do angle, side, angle. So I'm trying to make you understand that sometimes there's more than one way to prove it, but if you can prove it, you don't need to prove it multiple ways. So just pick a way and go with it, and you'll be fine. Okay, can you prove the triangle's congruent? Well, we have the 2 sides, but the angle is over here. So that's side angle, side angle, which is backwards ASS, donkey, and we know we can't do that. So can you prove your answers, or can you prove them congruent? No. And the reason, and I showed this video, I hope I can draw this on the fly. Probably not. Okay, so if you have side angle, the problem is this side here technically could flip and go over the other direction and still be congruent. And so since we don't know this other side, it could change. So again, I showed you this video in class. Hopefully you were there and you saw it. If not, I can send you the link. It explains it much better than probably what that illustration just did. So to justify your answer is the second side, which is this one, could flip the other direction. So the second side could flip the other direction. Okay. So I know this one looks really weird. This is an this is a flow proof, and it's actually really easy. So again, how many things do we have to prove? We have to prove 3. So 1, 2, those are the 2 up here, and those are both given. And then how do we know this one over here? Well, those are the vertical angles. So you're going to say vertical angle theorem. So do you have 3 things proven? Of course you do. So now you can just write your congruency statement. So the first triangle could be in any order. And so I'm just going to say RXQ. But now it has to go in corresponding order. So what corresponds with R? Is it T or S? Hopefully you're saying S. X corresponds with X and Q with T. All right, moving on. All right, so now we get to do some of these all on our own. Isn't this fun? Actually, I really do enjoy flow proofs. I'm going to do these flow proof just like we did this one. You will find that they are easier to do than the column proof. So I am told these two are parallel. Now, guys, whenever they tell you something is parallel, this is a hint for angles. So you're going to have like alternate interior angles. It's going to lead you to something else. Now, we also know these sides are congruent. So we need to find information because we don't have enough. Right now, we have one set of sides congruent. But if you have a pair of parallel lines and you have a transversal, you have alternate interior angles. All right, we're getting somewhere. Now the side in the middle, ZX, the length of ZX does not change from the top triangle to the bottom triangle. They share that side. So anytime they share a side, you can mark it congruent. It is reflexive. So, do we have enough information? Let's get back to this picture. I know I drew all over it. So, you have a side. You have a side in the middle, and it's all about where is the angle. It's in the middle. So, we're going to prove this by side, angle, side. Okay. Now, I like to write it over here so I don't forget in the middle of doing everything. So what we're going to do is we're going to do 3 steps because we have to prove 3 things. I have to prove a side, an angle, and a side. Oh, Microsoft stopped working, just kind of like in class. Great. Maybe it'll start again. Oh, nice. Well, you know what? I'll just go back. This is just like in class. I think there's a problem with OneNote. Okay. 1, 2, 3. And we said it was side, angle, side. All right. Let's start with something easy. That given information. So WX is congruent to YZ. Now, guys, this is how you do it. You put a box around it, just like up here. Do you notice there's boxes around those? And then underneath it, you tell me the reason, just like this one. Notice how here we wrote the reason underneath. So how did I know this? Well, this was given. Okay, now once you have something congruent, which I do, you're finished with that step. Now, if I'm doing my angle next, remember this was a hint for the angle. So I'm going to start here. WX is parallel to YZ. Put it in a box, hopefully not as ugly as mine here. This is given. Now, I know I'm not finished because look at the symbol. Is that a congruent symbol? Of course not. So let's keep going. What did the parallel line give us a hint for? It told us that we had a pair of alternate interior angles. So let's look at the picture. What is the name of this angle here and this angle? Now we're going to have to use 3 letters because if I just say angle X and angle Z, that's confusing. So let's do X first, this one. So let's use 3 letters, W, X, Z. Remember, your vertex is the middle letter. The first letter and the last letter could switch. Okay, let's do angle Z now. X, Z, Y. Okay, and you're going to say what kind of angles they are. Those are alternate interior angles. If you don't want to write definition, as long as you put alternate interior angles, you are good. Now, are you finished with this step? Do you see the symbol that means you're finished? Of course you do. Okay, so we get to move on. Now the last side is the reflexive side. So ZX is congruent to ZX. It is reflexive. Anytime they share a side, it is called the reflexive property. I am finished with this step because I have a congruency statement. I'm going to bring all three of these. This is called flow. It's kind of like pipes, 3 pipes flowing into one big pipe. So after I have my 3 steps, I'm going to write a congruency statement. Okay, and honestly, it's written right there for you. So I'm just going to rewrite it. WXZ is congruent to YZX. And you have to tell me which of those 5 little rules that we used. And hopefully you remember, and I wrote it over here. I'm using side, angle, side. Okay, so again, let's recap. How many steps will you have every time? That's not a highlighter. I will have 1, 2, 3 steps. Each step ends when you see a congruency statement after the congruency symbol, and then you bring them all together to write your congruency statement. Whew, that's a lot. Okay, but kids end up really liking these and enjoying them once they get the hang of it. So before I start, I know there are 3 steps. Okay, let's go through this information. H is the midpoint of GJ. So if H is the midpoint, what does that mean to us? That means that H is in the middle. So GH and HI are equal. So, I need 3 pieces of information. Right now I have 2. I need a third. And hopefully you're seeing that IH, they both share. And so that's another case of being reflexive. So they share IH. So how can you prove the triangle is congruent? Well, I have 3 sets of sides and they correspond. So I'm going to prove this by side, side, side. Okay, so I'm going to use side, side, side. And you can start with any of the sides that you want. It doesn't really matter. You just choose. We could start with the given up here if you like. H is the midpoint of GJ. Now, am I finished with this step? Do you see any congruency symbols at all? And hopefully you're saying no. So that means you have to move on. Because you see the word midpoint, that means the point's in the middle here. So what pieces are equal on this line? And again, hopefully you're saying from G to H and from H to J, those are equal. So G to H is congruent to H to J. And what definition did you use? You used the definition of midpoint. Okay, are you finished with this step? Yes, because there's a congruency symbol. Okay, now, on the picture, they tell you GI and IJ are equal. So let's go ahead and write that in. How do we know this? Well, it was on the picture. It was given to you, and I forgot to write given here. Now, am I finished with this step? I am, because there's a congruency symbol. I get to move on to my last step, which is my reflexive side. IH is congruent to IH, and this is reflexive property. And I'm finished. I have 3 congruency symbols. So now I get to bring all 3 of these together to write my big congruency statement, which is already listed here for me. So I'm just going to bring it down and write it. So GHI is congruent to JHI. And then underneath, you have to say which of the shortcut methods you used. And I used side, side, side. Okay, so it's a complete proof. Now, just quick note, these steps over here do not have to be in this order. You just have to list them. So the order doesn't matter. So even on this previous problem, I only write this SAS over on the side to kind of guide you what to do when kids are completely like clueless and don't have any idea what to do next. You can, as long as you have these steps, they can be in any order. So you don't technically have to do the side first and then the angle and then the side. All right, we have one more to do. And let's write in the information. Angle S and D are right angles. That's given. Now, AE is going to bisect, which means cut it in half to BD. Now, a lot of people get confused because they think everything's just being cut in half. Well, A to E is like the scissors. It's cutting the other segment. So the only thing that's congruent is B to C and C to D. So the segment A to E is still, we don't know anything about it. We just know it cuts it. Now we need 3 pieces of information, right? So we have 2. So you have to look at your picture and find your last piece of information. And hopefully you're seeing the vertical angles here. Okay, so before you start, you know there's 3 steps. I can go ahead and write that out. I have 2 angles and a side, and the side is directly in between. So I have 2 angles, and the side is directly in between. So I'm doing angle, side, angle. So guys, again, these 3 steps you're just explaining how you know these 3 things are congruent. Okay, so let's just start with the very first thing. Angle B and D are right angles, given. Okay, now I know I have to keep going because it doesn't show a congruency symbol there. So right angles, how do you know right angles are equal? Well, easy. We know all right angles are equal. So it's just all right angles are congruent. That's all you have to write. Now, and if you wrote definition of right angle, I would give it to you because you're trying, you're thinking, and you know we're done with this step because you have a congruency symbol. The next one, we have, let's see, this information up here, which was AE bisects BD. Now, again, there's not a congruency symbol, so I have to keep going. What 2 pieces of information are now congruent? And I did it in blue up here. BD is now congruent to CD. Now, I don't have anything underneath. I need to fill that in. So how did I know this very first step? Well, it was given to me. And on the second one, there's a vocab word that I applied. So in step 2 here, this vocab word was bisects. So it's definition of bisector. Okay, now step 3, I have the angles here in the middle. So you can't say angle C is congruent to angle C because that's way too confusing. you need to use 3 letters. Remember, the vertex is the middle letter. So let's do the one on the left first. So you could say ACB or BCA. So now let's do its vertical angle. The vertex has to be the middle. So I have ECD, or I could flip it and say DCE. So ECD. How do I know they're equal or congruent? Because of the vertical angle theorem. Okay, so all of this is going to merge together, and you're going to write your congruency statement, which is given to you. So let's just write it in. Triangle ABC is congruent to triangle EDC. And I know this because of, it's right up here, guys, ASA. And that is it. All right, so come to tutorials, ask questions, send me messages. I'm happy to help you anytime. Thanks. Bye.